Now you know, because you're not working hard enough, there's going to be a couple of more problems at the end of your homework that's going to be a little bit more fun. They're going to be hidden problems. Something like this. Find the domain. And it's going to say f of x, for example. F of x is the square root of 2x squared, minus 5x plus 2. And I'm going to get all saying, that's not fair, you never explained that. I don't know how to find the domain. Well, yeah, you do. What's the thing about square roots? What do we not like to do on square roots? We don't like to take the square root of a what? We don't like to take the square root of a negative, right? You don't. Make sure you remember this, because this is like section 1.9, I think. So if this is looking kind of strange, see the notes for 1.9, because I think that's where we really talk about this a lot. Let me check that out. Hold on. I'm crazy. There actually wasn't a 1.9. This particular one is 1.6. This is the sucker punch from section 1.6. So you might want to go review that a little bit. We don't want to take the square root of a negative. So what we're going to say is whatever's under the square root sign, whatever under the square root sign must be greater than or equal to 0, right? Whatever's under that square root sign, 2x squared minus 5x plus 2, has to be greater than or equal to 0. Now once you have that, solve like a regular problem, just like we've been doing through the rest of this assignment, the rest of this section. Alright, so write that and then solve it like you would everything else. I'm not going to go through that again because I think you've had to listen to this enough. So, similarly, if you have something like this is even more fun. It's the same thing. When you solve this problem for the domain, this thing here, 2x over x plus 1 minus 1, that has to be greater than or equal to 0. And then solve as usual. Alright? It's the same thing. Now there's another set of problems, and this one's like 1.7. And these are absolute values. So this is, I'm going to say C1.7 if you're short of this. So I'm going to do a quick assign, kind of a little bit of a review of 1.7. That's a really long section. We're not going too overboard. Remember we had something like this. We had absolute value of x was less than 5. And we said, how do we solve this? We said, all right, well, what we did is we actually wrote it out this way, just wrote it out. And then we said x is greater than or equal to negative 5. Remember, we switched the direction of the sign and added a negative. But then if we had something like this, we'd say, x is greater than 5, and then we'd switch the direction and add a negative. But there was something else that we did. Remember? I had this long, stupid story about how I'm super short and I can't reach the top things on the kitchen. So I'm super picky because the less than sign, if I'm super short, the less than sign means, or we had this associated with either and or. This one was associated with and. Remember the short person, I'm super picky, and, I'm super picky, picky is and. It's this one. It's our little inside the absolute value sign. Little pincers. If you don't remember this, again, see section 1.7. I talk about it for like 5.5 hours. Not quite that bad. But every time we had a less than sign, we joined these two with an and. Every time we had a greater than sign, we joined these with an or. Where this guy like doesn't care as long as it's greater than, no big deal. We join that with an or. So we're going to use that now, but we're going to use it along with solving lots and lots of problems. It's exciting. So we'll go ahead and work through an actual whole example for that. So say we had x squared plus 2x minus 36 greater than 12. So x squared plus 2x minus 36 is greater than 12. So that means, we'll write it once, we'll say x squared plus 2x minus 36 is greater than 12. And we'll write it again. We'll write x squared plus 2x minus 36 is, we flip the direction of the sign and add a negative. And we join these with a, because it's a greater than sign, we join it with an or. So now we've actually got two problems to solve, because solving it once wasn't good enough. So I'm actually going to go ahead and do this with you. So remember, the first thing I need to do is get everything to one side of the equation. Let's solve the one side first, then the other side. So I've got minus 48 is greater than 0. So I need to find this. So I will, that's supposed to be an equal sign. So you're probably getting kind of tired. Don't start this homework late, because it's not going to be fun. And this is a negative, so plus not minus. And after a little bit of finagling, I can get that these are my zeros. Like that. So x equals negative 8, and x equals 6. On these, am I going to include them? No, I'm not going to include, because it's a greater than sign. It's not an equal to sign, so I'm not going to include. So I'm going to graph myself something funky. So I've got a 6 and a negative 8. I'm going to have open circles on both. Oops. Come on. I have open circles on both. And I've got 3 sections. 1, 2, 3. So I'm going to draw my and then more stuff, and then more stuff. Like that. Alright. And I'm going to graph it. I'm going to graph this part. So I've got x squared plus 2x, come on, minus 48. And there's my 3 sections, section 1, section 2, section 3. So I've got an arm up, a loop under, and an arm up. I've got an arm up, a loop under, and an arm up. Since I'm going for, what was I going for? Greater than 0. Greater than 0 is this one. Not this one, but this one. This one's greater than 0 also. So that's my answer. I'm just going to stop. Okay, I'll just stop there for a second. We'll do the other side, then we'll worry about merging them. We don't need to write our interval notation yet. So that's our number line. So next side, we've got x squared. There, we need to add 12 to both sides. So see, we're going to get totally different answers. And this is why you have to actually work it out, which is kind of a bummer. Okay, so I need to solve this. Come on. There we go. So I've got this. These are x's, one's a plus, one's a minus, and as I finagle with it, pretending my brain was still on, which yours probably isn't, understandably, unless you're watching these like significant period of time apart, because this has been going on for a while. And we've got that. And again, we don't include, because we are looking for strictly less than, not equal to, not less than or equal to, strictly less than. Oops. So I'm gonna draw my number line. I've got a 4 and a negative 6. That's 0. I'm not going to include. So I'm going to draw my graph underneath and go like that. And I'm so tired. I just want this problem to be over, and it's not. It's so terrible. And I'm going to graph that thing. By that thing, I mean this thing. So I'm going to go x squared plus 2x minus 24. Come on, 24. 4. If I said it right, it would work. 24. Graph it. And there's my 3 sections. Up, down, and up. Up, down, and up. So, oops, I forgot to put my thingies in. Goodness, I'm just too excited. Up, down. Oops, that was a terrible. I'm going to try harder. I'm sorry. Up, down, and up. But I'm guessing I'm probably accurately reflecting your emotions at this stage. Looking for less than. So, less than. Not that one. This one's less than. Less than. Ugh, come on, I don't have time for this. I have TV to watch. And not that one. Alright. Are we done? Almost. We're so almost done. We are so almost done. We're doing or. Or. Okay, so I've got 2 things I'm oring. I'm going to take this one. I'm just going to redraw my graph, but I'm going to be a little bit more careful. So I'm oring this with this one. So there, that one, and it's connected. So I'm going to OR these 2. Oops, I'm going to OR. Come on. I'm going to OR these 2. So remember the OR. What did OR mean? OR meant either one, right? Either one. Either one. As long as I meet one or the other, I'm satisfied. Either one. So remember, the AND was the picky one. AND was the intersect. OR was the union. Do you remember what that looked like? Because remember, the AND was super picky. AND was just this section. But OR was everybody. OR was everyone. Like, you can come to my party, or you can come to my party, or you can come to my party. Anyone can come to my party, pretty much. So like you, or you, or you, or you, or you. So any of these people can play. So as I line these things up, I can say, make sure my zeros are always lined up. You, or you, or you, or you. So you can come to my party. Right, small. You can come to my party. Or you can come to my party. Or you can come to my party. So you can come, or you can come, you little green guy on the left, or you little blue guy in the middle, or you little green guy on the right. Any of y'all come to my party. So you, or you. So as I summarize this, you can come, or you can come, or you can come. You can come, or you can come, or you can come. So that means that any of these guys, if they want to, can come to my party. And that's like the, oh my gosh, I'm super awesome version of this problem. So if you can get through this one, you can pretty much get through anything. You say, well, I can't get through it. Well, you will. And by the time you go through all those other homework problems, by the time you get to this point, you should be in really, really good shape. And if not, obviously let me know. But again, if this is a little strange, make sure you go back and review 1.7 because you're going to need it for the final anyway, so you might as well. If the square roots give you a problem, make sure you go see the 1.6, the sucker punch section. But yeah, this is like the super, I'm ridiculously awesome problem. So if you need that, you're home free.